everybody, this is your host Murla Sharma, and today we will be starting our new series, Lawn Wars. Lawn Wars is just a game comparing two farmers' grass for whose is better. So today's contenders are Farmer Rowdy and Farmer Jolly. Let's call our contestants up. Please everybody give a big round of applause to our Farmer Rowdy.
Hello. Yo, here, Joe, guys. What day do potatoes hate the most? Friday. Get it?
Please everybody give a big round of applause to our second farmer, Farmer Jolly.
Hi, guys. I'm gonna win this.
Let me tell you a little about our farmers. Farmer Rowdy grows his grass without the use of pesticides, while Farmer Jolly does not grow his grass with the use of pesticides. So, after noting down that difference, let's see whose grass is better.
Did you know that?
Go.
Pesticides kill 18,000 farmers annually.
Hello everybody, we're back, and we're here with Farmer Rowdy. So Farmer Rowdy, how are you doing today?
I'm doing really well. How are you?
That's really good. So, please tell us, what type of pesticide are you using on your grass?
Well, I'm using the herbicide called Weed Be Gone. Alright? And this, it kills even tougher lawn weeds. So this is a really strong pet herbicide.
Alright, okay. So, wait, you just said herbicide. Why is that?
Herbicides are technically like types of pesticides who kill any weed or any, and they would call increase the growth of grass. And well, insecticides, which normally people think are like pesticides, those kill and those rely on like rotten tomatoes, and they make them like more appealing to the public.
Okay, that makes sense. So please tell me about this Weed Be Gone. What's in it? What are
Well, there are like three main chemicals, and there's like various small ingredients, but three main chemicals are called dimethylene salt of dichlorophenoacetic acid, which is 33.83% of this Weed Be Gone. The second chemical is dimethylene salt of 2-methyl-4-chlorophenoxypropionic acid, which is 8.17% of this.
Okay.
And the last component is dimethylene salt of dicamba, which is like a short term for dichloroacetic acid, which is 3.73% of this Weed Be Gone. And there's some other ingredients which account for 54.27% of this.
Okay, that's very nice.
So could you please tell me about the production of your product?
Alright, so well, since my product is mostly consisted of dichlorophenoxylacetic acid, which is 33.83% of it, I'll be discussing the reactants involved in that and the production of that.
Okay.
So, step one in producing dichlorophenoacetic acid is the phenol neutralization. The acidic phenol is neutralized with causatic soda. So the reactant in this is the dichlorophenol plus sodium hydroxide, which produces sodium dichlorphenate and water. This is a double displacement neutralization reaction because it's a acid and a base reacting to form a salt and a water.
See how smart our farmer is? He's even telling us the reaction type.
Alright, so step two is the sodium monochloroacetate is produced from another exothermic reaction. So the monochloroacetic acid reacts with sodium hydroxide, which produces sodium monochloroacetate and water. Step 3 is condensation, and step 2 is a double displacement reaction. And step 3 is condensation. The sodium dichlorphenate is condensed with sodium monochloroacetate to produce a sodium dichlorophenol.
Wow.
The sodium salt of the sodium dichlorophenol is reacted with sodium monochloroacetate to produce sodium dichlorophenoacetate plus sodium chloride.
So what type of reaction type would that be then?
That would be considered a double displacement reaction as well because there's two elements reacting and they just what we call the switch sides.
Okay.
The switch like the reactants. And step 4 is the final aging. The sodium dichlorphenate is combined with the sodium hydroxide to produce sodium 2,4-D, which is another short form for sodium 2,4-diprophenol. And this is an example of synthesis because two reactants are joined together to form one basic product.
Okay. You know what? Just because he had that much information, this guy's my boy. Right?
So-
He's my boy.
So after this short commercial break, we'll be talking to our next farmer, Farmer Jolly. This guy keeps losing. Did you know that?
More than 1 billion pounds of pesticides are applied in the U.S. every year.
Hello everybody, we're back with Farmer Jolly now. And I want to ask you first, how are you doing today?
I'm doing good.
That's very good. Alright, so I know you're a farmer who doesn't use pesticides. So do you want to tell me what are the pros and cons of pesticides?
Well, it makes it a lot easier. It's more efficient. You don't have to pull out the weeds individually. So it's way easier, less work.
Of course, like I understand, like there's less labor involved, and like you can just spray pesticides over your grass, and like there's better results, right? So I'm pretty sure because there are so many like pros, there's also a lot of cons, right?
There are many cons.
Okay. Could you please tell me some of the cons with using pesticides?
Okay. This pesticide may be toxic to fish and aquatic invertebrates and may
Okay.
adversely affect non-target plants.
Oh, okay.
This chemical has properties and characteristics associated with chemicals detected underground water.
Wow. So meaning it could like affect like the fishes in our ecosystem, and like we eat the fishes, so it could also affect us in the future, maybe.
Yes.
Okay. Wow, that's good information. Well, after this, we'll be talking to our scientist, Sahibjot, alright? So we're with my good friend, Dr. Sahibjot. So, Dr. Sahibjot, tell me how you're doing today.
I'm doing fairly well. How about yourself?
good. Very well. All right. So you want to tell me about some of the waste created with using pesticides?
Well, there actually are many wastes created when you start to produce pesticides. Right, an example of this could be the principal air pollutants. Right, they're considered volatile organic compounds, otherwise known as VOCs. Right, and they also make something called PMs, particulate matter.
Okay.
Now, also liquid waste, otherwise known as liquid effluents. Right, that are often result from when you're cleaning the equipment that you used to produce the actual pesticides. Right, and these often go inside the water and make the water toxic. Which is, of course, bad for fish. Many people enjoy fish, right? But it's horrible for them. It makes them extremely unhealthy. Now, cooling waters, right, that they use to actually cool the instruments after they're done using them, they're often recirculated, right? And that makes them extremely, extremely unhealthy and toxic. And then after that, they usually put them inside with other water. Just throw it out like throw it in like a sink, for example, right? So that's extremely bad.
Oh, very nice.
Yeah.
So after hearing that, I would actually think twice before using pesticides because of the waste created. So now we'll move over to our Lawn Wars and we'll have our determined answer ready to go.
We're on, buddy.
Oh, okay. So now we'll be declaring who the winner of Lawn Wars is. So, drum roll please. And our winner is Farmer Rowdy.
Start.
So, Mr. Rowdy, tell me how you feel as being the winner.
I feel like I'm the king of the world. Weed Be Gone is the greatest pesticide ever.
Well, our rules didn't apply for who served the best purpose for the world. Who cares about the environment? Our grass should be green. Yay!